So first up, all right, I have point A and its image, point R. What's my scale factor? Well, it's actually in the directions. Here's a huge help in the directions that this dilation is centered at the origin. Why does that help me out so much? Well, I can do my shortcut. I can use the shortcut from yesterday. Remember the shortcut? If I am centered at the origin, I just take the scale factor and multiply by it, right? The x and the y coordinates. Well, you know the x and the y. Now you got to figure out what you're multiplying by. And I know number one's pretty easy, right? How do I go from 3 to 9 and 4 to 12 by multiplying? And again, why do I know it's multiplication? It's centered at the origin. All right, so real quick, centered at the origin, what's my scale factor going to be for this one here? 15, that's one less than z, and that would go not to Gabby, but in between. Are you 15?
Yeah.
You are? All right, never mind. Again, I have no, like, Amy, you were absent the other day. I had no idea who sat there. No idea. Obviously, I know you all year long, but totally blanked on who sat there. Okay, Will, I did remember you sat there.
I don't even know the names of everyone in this class, so.
Yeah, there you go. Thank you. Thank you. There you go.
Wait, who don't you know?
Don't start. All right, you already got me fired up.
Nah, I think we
All right,
should start.
no, don't start.
I don't know your name.
All right, don't start. All right, Gabby, what's my scale factor?
3.
3. Yep. And I'm going to start using the notation your textbook used last night on the assignment. K equals 3. All right, well, that's pretty obvious. All right, I know everybody can here find the scale factor is 3. Sometimes it's not obvious. Like, how do I go from 9 to 6 and 12 to 8? And I don't want to keep guessing and checking. I know it's not a whole number. So what I would suggest instead is, hey, why don't you just set up yourself a quick equation? Say 9 times my scale factor should give me 6. Set up a quick equation if it's not obvious to you, like the last one was. All right, or I could do 12k equals 8. Either way, I'm not even going to bother. 10. Matt, thanks, Matt.
3/4. No. Oh yeah, 2/3. Wait.
3/4.
2/3.
Which one is it?
2/3.
2/3. All right. It's always an adventure when you get up there, Matt. Yeah, 2/3. Thank you. And also thank you to Matt for not doing 0.66666. Leave it as a fraction. All right. Leave it as a fraction. And then finally over here, -2 to -10, -3 to -15. If it's not obvious to you, set up an equation. That's not a big deal. All right. Set up an equation. Here we go. 9. 5. Yep. All right. No issues there? All right, now what if I gave you a graph and asked you to find the scale factor? Well, good news for us, right? If you read through it, the center is still at the origin. But just please be aware, polygon B is the image. So we're going from A to B in each diagram, A to B. So even before I find the actual number for the scale factor in number 4, if I'm looking A to B is getting smaller, so at least I know I should have an answer between 0 and 1. All right, if it's getting smaller. My suggestion, pick 2 points and make this into the last 3 problems we just did. So I take point A here, which looks to be 3, -3. I match it up with its corresponding point right here, 1, -1. And now I just turn it into the problem we just did. How do I go from 3, -3 to 1, -1?
I just really noticed that you take the first, like the x coordinate of the image, you put it over the x coordinate of the pre-image. Doesn't that just give you the scale factor?
As long as it's the origin. Be careful. If it's not the origin, I got to count with the slope, right? But yes, if it is the origin, that's exactly how it works. Yep. 13. Yeah, thank you. I'm going to start trying to memorize these now.
Is it 1/3?
It is 1/3. Yep. There you go. If you gave me 3, remember 3 would say the figure's getting bigger. All right, it's getting smaller. All right, you guys are on 5 and 6. All right, you guys are on 5 and 6. What was your scale factor for number 5? Scale factor for number 5. 15. Gabby?
1/3.
1/3. Good. Whoa. For number 5, it's a third?
Oh.
Sorry.
2.5.
2.5. Yep. I'll leave it as 5 halves, but you can certainly have 2.5. And then how about number 6? 12. Oh, no. I was going to try one less than her, so I was going to try to do the alphabet. Go ahead, Olivia. 1/3. That's the 1/3. Good. All right. Good work, everyone. Any questions, comments? All right. This next one I got off an old Regents. The prime one's the image, like we would assume. Describe the transformation that was performed. Well, now we have 4, right? We have rotation, reflection, dilation, and translation. But if we look here, it can't be one of the first 3 I showed you because these are different sizes. So it's got to be a dilation. And my expectations don't change, though. Just like we were saying rotation, reflection, translation, I said get specific. If it's a rotation, how many degrees? Well, if it's a dilation, what's this darn scale factor? I just don't want to write the word dilation. So a dilation with scale factor, and then I'll let you guys find that one. And remember, try it on a couple points. Just don't, here's my issue. If you do it on A, -2, 4 to A prime, which I think is -5, 10, you find the scale factor for that, but don't assume that's the scale factor, because what if I'm not centered around the origin? To confirm that, I would do B and B prime and make sure it's the same scale factor, because if it is, we definitely know it's centered at the origin. All right, if you can multiply by the same number. So just don't be satisfied with A to A prime. At least try B to B prime as well before you tell me the scale factor.
Yeah.
All right, what was our scale factor here for these triangles? Scale factor?
2.5.
I was going to try to guess, but okay. Scale factor of 2.5. I still need one other thing because there's 2 things I always give you for dilation. Scale factor and center of dilation. So scale factor of 2.5 centered at 0, 0, or at the origin. There we go. Part B. Explain why they're similar. What do you know about similar triangles? We spent a whole darn unit on it. See, similar triangles?
Angle measures are equal.
Angle measurements stay the same. And do angle measurements stay the same in a dilation? Yes, they do. Sides don't, but angles do when you dilate. So we're going to write, no pun intended here, something similar to what we wrote for congruent triangles where we said rigid motions. Well, it's not a rigid motion, right? So I can't say that. But what I'll say is this, though. Dilations preserve. What does it preserve? Angle measure, right? Remember we put distance and angle measure before for congruent triangles. Well, the distance isn't preserved, but angle measure is. So dilations preserve angle measure. Ooh, big moment for one of you right now. Big moment. Big moment. 15. Gabby, what do you want to use?
Wait, what?
What word do you want to use?
Ergo.
Okay, you got it. Ergo. Triangle A prime, B prime, C prime. Similar. How many of you are writing congruent right now? Don't be embarrassing. To ABC. All good? All right, you ready? Go ahead, grab those compasses. It's been since unit 5. 5 since we've used the compass. Everyone remember how to use them. You need to stretch the wrists out. We're all good. Doyle, you good? You were lefty or righty?
Righty.
Okay, so you should be okay then. Because I would have loved to see that on the other hand.
It's true.
Why?
Snake in the struggle.
Okay, get over it. You know, right, Doyle? Find a way. All right, no excuses in here. All right, before I show you how to do dilations, I want to quickly talk about this and see how much you've actually learned from dilations. We're going to dilate this triangle with a scale factor of 1/2. What's going to happen? By the time we're done, what's this going to look like?
Half the size.
What, Matt?
Only half the size.
It's going to get smaller, right? Why is it going to get smaller? What's going to happen to A, R, and T? Where are they going to move? Describe where they're going to move.
Closer to O.
Closer to O. How much closer, Ian?
Half.
Half the distance from O. So that's our job right now. Get A, R, and T half the distance to O. And you guys know how to do this. I just got to review it. So let's start with point A. Let's get point A half the distance closer. Connect A and O with your straight edge, please. Connect that distance, right? Connect it. Connect that distance to A to O. All right, I don't know, who cares how long it is, but I need half that distance to put A prime on. Half? Half? Is there anything we've used in the past that can find half? There we go. There we go, Haley. Talk to us. What are you about to do there?
I don't know. I was just like.
I thought you were taking your compass and putting it on one of the endpoints and opening it.
More than half.
There you go. More than half. Right? We're making about a half circle size arc. Keep our compass open the same amount and go to the other endpoint, either A or O. Anybody remember how many points of intersection I need here? 2, right? Don't stop after 1. I need 2. Do not pick up your straight edge yet. All right, don't pick up your straight edge yet. Just get those 2 points of intersection made. All right, pick up your straight edge. But do not draw the line through. You can. It's just more lines on your paper than you need. All right, so line it up. Line up your straight edge. What are you only interested in? The point that's halfway to O. All right, so just make a point there. All right, you don't need to draw the full line in. It's just an extra line that's just going to make things a mess. So find the halfway point, which I know I'm going to say right about here. And guess what? That's going to be A. That's the midpoint and also A prime. So now you've moved A closer, half the distance closer. And now we got to do it 2 more times on R and T. All right, so you guys choose. You guys go ahead, do your own pace. I apologize. I already know T and O are pretty close together, and you got to still cut that in half. Suck it up.
Mr. Carlino, do you have any older siblings?
Older? No, I have 1 younger sister. That's it.
Has a kid ever called you by your first name?
No. Yeah. Or if they have, they think they're funny and they're not. Yeah. Hopefully you do have a triangle that is smaller than the original and getting closer to O. Questions? All right. I can definitely tell some of you have not used this compass since Unit 5. Oof. Look at some of these arcs. Might as well just put the compass in your mouth and do it. Same. All right, any issues? None here? All right, let's go now, just so we're aware, I know we're in honors and I make that a point almost every day, but I will probably not do anything different than 1/2. Okay, I won't do 1/4 where now we have to cut this in half and do it that way. Probably 1/2 is where we'll stay, anything less than 0. All right, anything less than 1. Greater than 1 though.
That's awesome. Slide left.
Why? Why? Of all classes.
Slide right. Hey, page girl.
We already know what's going to happen, so why are we even doing this?
Claw.
Okay, you gotta relax.
Wheel. Drop. Swing. Star. Cube. Yeah, we need 2 more.
What are we missing?
Is cube with a height? Can I not count? Is that 16?
Oh, we're missing one. That's a shame.
Maybe it's a star.
We are missing one. Oh, never mind. Nope, there it is. I thought it was Genie. We got Genie up there. All right, we ready here? We already know it's just a waste of time now. You guys are awful at this. Star. Flip. Fade. Swing. Wipe. Drop. Pinwheel. You guys screw it up all the time. Clock. Cube. Shatter. Genie. Book. Curl. Curtains. Slide right. Slide left.
Can I change my vote?
No.
Please.
So I'm giving you 5 now again. 5,
Oh, yeah.
including the Promethean person.
Yeah.
Right?
Yeah.
Flip, fade, swing, slide right.
Yeah.
Promethean person for no homework. It's the only way you're going to get it is if you can have a 5. All right, let's go. I don't have any more slides. We'll back up one.
Like you always saying that.
Yeah, I know, and it's always true. All right, what are we on again? Swing, fade, flip, slide right. Swing, fade, flip, and slide right. Swing, fade, flip, slide right. Ready? That is the best thing that could have ever happened right there. Yes. Remember me? Yep. And we go 0 for whatever now. Keep it up, kids. Keep it up. Keep it. Each girl coming through for me. Here we go. Are we ready? All right, now let's go in the opposite direction. Now let's have a scale factor bigger than 2. So yes, the triangle is going to get bigger. Points are going to get further away, but there's a little twist here. Anybody notice where we're dilating around now? If you read the directions.
B.
Point B. So guess where B is going? Nowhere. Oh, vocabulary quiz. It means it's what type of point then? Oh, invariant point. There we go. Invincible, whatever you guys called it yesterday. Yep. B. What? That was this class, wasn't it? Somebody had it, or maybe it was a different class. Yeah, never mind. I feel like it should have been this class. B prime. It's going to stay where it is. All right, now let's dilate A and C. Scale factor of 2. They're going to get further away, though, right? For double the distance away A is from B right now. Extend AB. Extend AB. Using your compass, measure the distance from A to B. Measure the distance from A to B. How can I double it then? How do I now double it to find out where A prime is?
The point of the compass on A.
Now slide it up. Yeah. Put your compass on point A. There it is. That distance has now been doubled. From B, anyway. And make your arc mark on your extended side, and that becomes A prime. And same thing now, extend BC a little more, and copy BC onto there. I did not make it long enough.
Would we lose points if we don't write B prime?
I probably wouldn't, no. As long as I don't see B prime somewhere else. I wouldn't. And there it is, an enlarged triangle. Last thing here, is this image of triangle ABC similar to the original triangle? Yes, it is. We know that from today, right? Yes. Dilations. Preserve. Angle measure. All right, lead us into the weekend strong now, your 3-day weekend coming up. Charlie, what do we want? Therefore, all right, as long as it's not thus. Oh, I drew a blank there. Therefore, triangle ABC similar to triangle A prime, B prime, C prime.